this time we're doing 4.5. This is a drawing that I've done. It's two vectors that they've put together and then told us all this information about. It's not drawn to scale at all, so don't judge me. So the first part it asks us is to find the x and y components of the final vector. And so how we're going to do that is find the x and y components of these two vectors and then add them together. So for this first one here, we're going to call that vector 1. And we are going to find its x component, which is going to be right here. We're going to do that by doing 9.0 times the cosine of the angle that it gave us. And that gives us the x component. And the reason we did that is because cosine of our angle is equal to the opposite over hypotenuse. So then just quickly doing that calculation in your mind just multiplies that. And that's how we solve for x. Okay, then to do the y component, it's going to be similar. This time it's going to be 9.0 sine of 60. And for the second vector, we're going to have x is equal to the hypotenuse times cosine over the angle again. And then same thing for y. Hypotenuse times, times the sine of our angle. Okay, and then those numbers give us 4.5 newtons, 7.79, 3.60, and 4.80. Okay, now we just have to add some directions in here because these are the quadrants that it told us to place them in. So the x direction is going negative, sorry. And then the x direction is going negative for both of these ones. Let's see, x. And then the y direction in this one is going negative. So that's how we put those ones. Okay, so then our v total is going to be both of the x's added together, so negative 4.5 plus negative 3.60, and then the y's added together, which is going to be 7.79 plus negative 4.80. And then when we add those together, we find that our vector is negative 8.1 in the x direction, or I, and then 2.99 in the y direction, which is j. So that would be our total vector. Then, when we're finding the magnitude of it, we just have to take this, it's pretty much like solving the hypotenuse of our vector. So what we just barely did is it tells us it goes negative 8.1 in the x direction and about 3 in the y direction, like that. And then we draw our vector. So then in order for us to find the magnitude of it, we just take that x and we take that y and we find the hypotenuse of it, which will tell us the magnitude. So we're going to take the square root of our x squared, and it's negative, but that doesn't matter too much. And then plus the other one, 2.99 squared. And then when we solve that, we get 8.63 newtons is the magnitude of the last vector.